Welcome to my final presentation for my capstone project for my computer science degree at BYU, Idaho. I'm really grateful for the opportunity I've had to work on this project. It's been a lot of fun and I've learned so much. So my project is based very heavily on the Kinetic 700 dataset, which is a combination of thousands of videos that have one of 700 labels of different topics or themes of a video. And due to computational limits, this being a local trained model on an 8 GB graphics card, I wanted to cut these down to about 15. So the 15 that it's going to be training to predict a video toward is animals and outdoor, arts and crafts, athletics and fitness, ball and court sports, combat and martial, driving and transport, food and drink, games and media, grooming and appearance, health and habits, home and DIY, music, dance performance, social and family, water, winter sports, and work and errands. So what this dataset consists of, the Kinetic 700 dataset, it is a big JSON of a bunch of YouTube links that have labels attached to them. So this URL is a javelin throw and so on and so forth, but it's a big data set. This is 1/6 of the entire data set because I did not need all of it, especially for storage concerns, as we'll get to in a moment. So the goal in the beginning was to download the videos and have them be classified in one of these 15. And an example of this working is this PNG here, which shows our console where we have previously downloaded 9,750 videos with a goal of 650 per class. For this example screenshot, I downloaded 25 more, and it shows what categories they are under, and successfully downloaded 22 out of 25. After that, it will change it to, if we go to our data process labeled, it turns each video downloaded into a folder that has up to 16 frames and an audio.wav file, which has the audio of the video. So as you can see, the 16 frames are an event happening in the video, and then the audio is the audio behind the video for the model. Once it has all this information, it will add them to a learnable format. So we have checking validity of the data, and then we have our biggest two functions, which are load frames and load audio. So load frames will take all of the frames from the video and get them ready to be put into the model, which we'll get to in a moment. And it will do the same thing with audio, except in audio, there's a little more preparation than just the getting of the frames, because with audio, it has to make the Mel spectrogram, which it does. In this project, I had some issues with low accuracy because I underestimated the scale of it by quite a lot. So I'm going to walk through some things I did here to increase its accuracy. So one thing I did was augmentation added to the data set. So even though we had just under 10,000 videos, I needed to add more data to it, but storage was getting a little tight for this project, as this is over a couple hundred gigabytes. So what it does is when it's giving it to the model, it has augmentation to the frames, which it will crop it different ways, it will flip it, and it will add color to it, just so then we can prevent overfitting even a little bit. And with the Mel spectrogram, it does a similar thing, where it will augment it by changing the time when it starts, when it stops, changing the scale of it, and either multiplying all of it by 1/2 or 2. And this ended up increasing the accuracy of the model by 15%, along with some other things I will get to. For the training, we could see, where is it? So for each batch it gives to the training, it ensures that it has the video, the audio, and the labels um, to ensure that the system processes both video and audio for the machine learning model. And for that model, its embeddings are as follows. It has two groups of 256 dimension, one for audio and one for video, and then it concatenates the both of them to a 512 dimension input for the model, for the feature fusion layer. And then it will all go down to 15, a dimension of 15 at the end. And I can show you that now. We have our evaluation of the model. Some other things that I added to this project to kind of increase its function was backbone freezing. So for the version of Torch I was using, it was ResNet 18, which has some basic object recognition in it, and I did not want to change that or learn on that, so I would freeze the backbone of the model so that I could just train on new information that it gathers outside of what it was basically trained on. And this helped a lot with our training as well. And I also added weight deterioration, where it would slowly wean off weights so that it would not overfit on this data. And back to the evaluation, our accuracy ended up being about 49.41%, which was a big step up. Before I added those other optimizations, it was about 35%. But I'm very proud with the 50% I've been able to get to now, and it definitely has some strong suits. Like ball and court sports, it is very good at observing, as well as water winter sports, driving and transport, work and errands, grooming and appearance. I think these are much more, they're louder videos on average, and they're also very visual in what they are, which is why social and family and athletics and fitness, home DIY, games media, and combat and martial have also scored as our lowest 5. Here's the confusion matrix of the following. This is more just for the presentation, as I went off of the logs of the evaluations instead of the confusion matrix, but I'm happy to show one. And for the last part of this project, we have the online portion, where this has a website. This is locally hosted at the moment, where we can drop a video in and then it will run it through the model after it splits it to 16 frames of the video and then to the .wav file, and finds the male spectrogram, the male spectrogram of the audio, and runs it through the model. And to make sure it's not biased or a video I've already given it, we're going to search on pixels just for football. And I've been watching a lot of the World Cup recently, so this is what came to mind. We'll take this one. So now that we have this video, we can drag and drop it into here and run our prediction. So it has a prediction of ball and court sports at 75.68%, with athletics and physics and fitness being 10%, and water and winter sports following. Its accuracy is really good towards sports related things, as I've shown, and I'm really happy with how this project has turned out. I've learned so much about multi-data models. So combining two data types that are very different, such as audio and video, has been a very big challenge, and I did not know quite how difficult this kind of machine learning is, but it is. But I've learned a lot, and I'm grateful for the opportunity I've had to work on it. Thank you.